Yes, the topic is projection of straight lines. Consider a question given like this: a line AB. AB is the length of the line, is 100 mm long, is inclined at 30 degree to HP and 45 degree to VP, with the end A 25 mm above HP and 35 mm in front of VP. Draw its projections. So asked to draw the projections. Projections means drawing the front view and the top view of the given straight line of length 100 mm. So let us get to the description of the straight line. Consider this as a straight line having end points. This end point is A, another end point is B, and consider the length of the line is 100 mm. So when I place a line like this on the first quadrant, this is a position of the given line, and this point A is located. The point A is located at a distance of 25 mm above HP. It's given in the question itself. Point A is 25 mm above HP. This is distance above HP, and 35 mm in front of VP. In front means this distance, this horizontal distance called in front of VP. 35 mm in front of VP. And the point can be represented by this. It's a red color. Consider this is point A, and it is projected on the vertical plane as A dash. It is projected on the vertical plane as A dash, and similarly the point A is also projected on the horizontal plane as point A. After projecting the end points of A, and that can be indicated in the diagram. Take your drafter scale. So take your drafter scale and draw the reference line called as XY line, which connects the vertical plane and the horizontal plane. This pink color, this is a reference line which connects the XY. It's called XY line connecting the vertical plane and the horizontal plane. It's drawn first using the horizontal scale of your drafter. Indicated as X and Y. X and Y. So on this, what is called as the reference line, the distance above HP, the point A is located 25 mm above HP. From the XY line, locate a point at a distance of 25 mm. It's marked as A dash. A dash is a point given to the front view of the point A dash. And you have to dimension this. This 25 mm above HP needs to be dimensioned. 25 is written, and after projecting on the vertical plane as A dash, and as per the orthographic projections, the horizontal plane is to be rotated clockwise 90 degrees. This is the direction of clockwise, and for rotating the clockwise into 90 degree, I am removing this hook provided on this horizontal plane. When I release this hook, you can see that the 35 mm in front of VP. The distance earlier, the distance in front of VP is 35 mm. This comes below the XY line. So that has to be indicated in the drawing. So from the XY line, draw a distance, that is using your projection line, drawn by using 2H pencil. A line is drawn, and the distance below the XY line is taken as 35 mm. Put a point on 35 mm. This point is marked as, say, A. A is the point on the top view. The top view will come below the XY line, reference line of the given point A of the straight line AB. This is point A. And the distance is also dimensioned using dimension line by providing two arrows on both the ends, written as 35. And after projecting the point A dash and A on the sheet, the drawing sheet, as the line is inclined at 30 degree to HP, it is given in the question, inclined at 30 degree to HP. So as the line was earlier like this, point A is situated 25 mm above HP and inclined at 30 degree to HP. So this angle of inclination is 30 degree. Angle of inclination is 30 degree. And these end points, another end point is B, is projected on the vertical plane as B1 dash. Say B1 dash, that is, this is a point, and this angle is 30 degrees, seen in the front view. So as you are the observer, seeing in this direction, and the point, this angle of inclination of the line AB shall be seen in the front view. Suppose if the angle of inclination is 0 degree, it may be like this, horizontal, and when the angle of inclination as it increases up to 30 degree, you can see this angle of inclination 30 degree in the front view itself, and that has to be represented in the drawing sheet. So take your protractor, and before that draw one reference, that is called as a 2H line, that is a pencil used to draw the projection line like this. It's a line passing through, horizontal line passing through point A dash, and this as a reference, this point is called A dash, and with this red color line as reference, put a point at an angle of 30 degree, mark 30 degree angle, and using a drafter scale, adjust your scale and connect the end point, that is connect the marked point with the A dash. Reduce your scale of a drafter, rotate it anti-clockwise, adjust the scale so that you can join the line, that is a marked point and the A dash, and the length of the line is given in the front view as, that is a true length, shall be seen in the front view as 100 mm is given. This is the end of the line, showing the true length, whatever length is there, 100 mm. This point is marked as say B1 dash. B1 dash. Understand? Now we are going to draw the projection line. Projection lines shall be drawn by using 2H pencil, shown here, shown in red in color. So I just reset your drafter scale, keep it on the XY line, so that this line, the horizontal scale is perfectly horizontal, 0 degree. Now using the shorter scale of a drafter, draw the projection line like this. And the point where you mark the A, there you draw one horizontal line using, that is object line called the top view of the given line. This point is marked as say B. Here B1 dash is provided, so it has to be B1, B suffix 1. So this is the angle of inclination, that is theta. Theta is the angle, inclination with HP, as given in the question, HP 30 degree. So this angle is marked and it is indicated by arrowheads on both ends. So theta equal to 30 degree. Theta is the angle used to denote the inclination with HP, 30 degree. So as you can able to recall, as the line was kept like this initially, at a height of 25 mm above HP. One end of the line A is located, one end point. This is the previously shown like this, and this is the end point A, another end point is B. It's projected on the vertical plane as A dash and B1 dash, another end point. And top view is projected on the horizontal plane as B1. This point A is projected on the horizontal plane as small a, and another end point B is projected on the horizontal plane as B1. It falls on the horizontal plane as B1. And you can find the true length, whatever length is there, 100 mm, that can be seen in the front view itself. True length, you can see it. You can see the 100 mm length in the front view. And the top view length will diminish, will be lesser in length, so it will be shorter. And after projection, it can be indicated in the HP like this. This length A B1 will be shorter compared to the true length A dash B1 dash, which is 100 mm. Suppose if the angle of inclination increases, say some 70 degree. 70 degree will be greater than 30 degree. In that case, the point will be located. That is another end point called B. May be projected on the horizontal plane for the 70 degree angle will be may fall in the horizontal plane as here. Suppose if that can be indicated in the top view as maybe at here called B suffix 1. B suffix 1. But whereas here the angle of inclination is theta is 30 degree, for that the corresponding top view will be A B1. AB1 indicated. So this is step number 1. And 35 mm is a distance in front of VP. In front will always come below the XY line, and 25 mm above HP will come above the XY line. That you have to remember. Next, followed in step 2. In step 2, now consider the line is inclined to VP alone. What is the angle of inclination given in the question? Inclined to VP. 45 degree inclined to VP. Now consider in step 2, the line, straight line AB is inclined at 45 degree to VP alone. So for that, this is a position of the line. This A point is located 25 mm above HP, that remains the same. And end point A is 35 mm in front of VP, that also remains the same. And the angle of inclination called pi, that is inclined to VP, is this is the angle, 45 degree inclined to VP. Suppose if the line makes 0 degree with VP, it may be kept like this. Now it is parallel to HP and VP. And now it makes 45 degree with the VP. So I have to tilt like this, turning this AB line, and maybe kept like this. And this angle is called inclined to VP. This angle, 45 degree is the angle. And the point A and B are projected on the respective planes. This is point A, is projected on the vertical plane as A dash, as said previously. And point A is also projected on the horizontal plane as A. That is shown, and it will be visible in the horizontal plane. And point B is also projected, this point B is projected on the vertical plane as B2 dash, B2 dash. And notation given called B2 dash, like this. As a ray, it falls on the vertical plane, VP, vertical plane as B2. And the further in the point B is also projected on the horizontal plane as B2. So after projecting the end points of the given straight line 100 mm length AB on the respective planes, the horizontal plane is to be rotated clockwise to get to the top view, like this. This is a clockwise direction, and you can see this angle of inclination inclined to VP in the top view. The top view, as I told you earlier in the previous video, when the line is inclined to VP, that angle of inclination will be visible in the top view only. Suppose if the line is inclined to HP alone, that is seen, the angle of inclination will be visible in the front view. That we have drawn in step 1. Now consider that the line as if it is only inclined to VP alone. In this case, take your horizontal scale of your drafter, draw the XY line. This is the XY line called the reference line, which connects the VP and the HP. Mark the X and Y. And point A is located 25 mm above HP. That remains the same. Put a point at the height of 25 mm. And 35 mm in front of VP. In front will always come below the XY line. This is the distance. On the same line it will come. That is A dash. This A. And both are connected by dimension. That is called as a projection line. Both are connected by projection line. Both will fall in the same vertical line. And the distance is to be dimensioned. So dimensioning is important in every case. And 35 in front of VP, that distance will always come below the XY line. That I have to remember. And this is point A dash and this is point A. And the line is inclined to VP. Whenever a line is inclined to VP, that angle of inclination will come in the top view, that is below the XY line. So draw one 2H line like this from point A using your 2H pencil. And the angle of inclination with VP is given as 45 degree. Take your protractor, mark an angle of 45 degree, keeping the center of the protractor over this point A. This will be 0 degree horizontal. Put a point at an angle of 45. So adjust your drafter scale, release the nut of your drafter, join the marked points with the point A, and tighten your drafter scale so that you can locate a point at a distance of 100 mm on this inclined line. It's marked as B2. That is B2 is a notation given at the end point called B. And use your 2H pencil. Reset your drafter scale to horizontal, keeping on the XY line as reference. From B2, draw a vertical projector using your 2H pencil. And from point A dash, draw the horizontal line that will show the front view when the line is inclined to VP alone. This point is B2 dash. And in this diagram, step 2, it is shown that the line is inclined to VP alone. And this is the angle of inclination called pi 45 degree. It's mentioned as pi equal to 45 degree. Pi equal to 45 degree. And now we are going to, in step 3, I am going to combine the step 1 and the step 2. Here in step 1, the angle of inclination is 30 degree inclined to HP alone. In step 2, inclined to VP alone. Now we combine step 1 and step 2, forms the third diagram, and the final front view and final top view shall be drawn as per the given notation. Next, in final step, I have to combine this step 1 and step 2. So step 1 is again redrawn like this. It appears like the same. 25 mm above HP, 35 mm in front of VP, and this angle theta is marked as theta equal to 30 degree. That is theta. And the top view for the only as if the line is inclined to HP alone. Next, I have to combine this diagram, this into this. So again, I have to take a drafter scale and draw one horizontal line. That is, this is the line, and the angle 45 degree is to be marked. Take a protractor, put a point at an angle of 45 degree. So as the line is inclined to VP around, this you have to combine in this. So combine in step 1 and step 2, mark 45 degree. Adjust your drafter scale, join A and mark the point, join it. Then tight your drafter scale. This point shall be marked as, say, B2. And I have to draw this red color line called the projection line by using 2H pencil. Reset your drafter scale to horizontal. Tight your scale. From B2, draw a vertical projector. And this point, from B2, the vertical projector, where it meets the horizontal line passing through point A dash. Passing through point A dash shall be marked as B2 dash. This is A dash. This point will be marked as, say, B2 dash. Yeah, now the two diagrams are just combined in this final step, and this is the angle of inclination called pi, inclined to VP. So pi equal to 45 degree. And in the final step, to obtain the final projections called the final front view and final top view, take your compass, and before that I have to draw a locus line for the front view and for the top view. So take your drafter scale, draw the locus line passing through point B1 dash in the front view. So reset your drafter scale to horizontal line, keep it on the XY line, and tight the drafter scale by rotating the nut in clockwise. From B1 dash, this is the point B1 dash, draw one horizontal line called the locus line passing through point B1. Similarly for B2, draw one locus line. Locus is a line having two or more points passing through the same line. So locus of B, and this will be a locus line for B, called locus So take your compass, keeping A dash as the center of your compass, A dash as center, and B2 dash as the radius. A dash and B2 dash as distance in your compass. Draw an arc like this upward. So this arc where it intersects with the locus line, that point is marked as, say, B dash. This point of intersection with the locus is marked as, this point is called B dash. And also in the top view, to get the final top view, keep A dash as center. A dash as center, A, B1 distance in your compass. Draw an arc. The arc where it intersects with the locus of B. That point is marked as, say, B. This point would be B. Now the final front view will be A dash and B dash. Final top view will be A and B. Has to be joined. These final drawings, the final front view and final top views shall be indicated by using HB pencil. As this is the final answer, use your freehand scale or use your drafter scale. Join A dash and B dash. Drawn by HB pencil. This is the final projections. The question is asked to draw the projections. That is the final front view. A dash B dash is the final front view, and AB is the final top view. That has to be drawn by HB pencil. Looks darker. And other lines are called construction lines, drawn by H pencil and 2H pencil. The red colors are drawn by using 2H pencil called the projection line, and this inclined to HP, inclined to VP, these lines are drawn by using H pencil. And final answer, A dash, B dash and AB top view shall be indicated by HB pencil. That's an object line, as that denotes the final answer for the given question. Draw its projections. And in this you have to remember that this A dash, B dash is the final front view, AB is the final top view. And further there is two more angles are there called alpha and beta. Alpha is the angle of inclination of the front view with HP. Alpha is the angle front view inclination, and beta is the angle that is top view inclination. Here the angle of inclination is alpha. This angle is called as alpha. I have to mention in the diagram. This is final front view, A dash, B dash. This angle is called alpha. Similarly, the final top view. Final top view has to be mentioned by a notation called beta. That is, AB is the final top view, and this angle is called beta. So there are two angles, theta, pi. Theta is the angle indicate the inclination with HP. Pi is the angle inclination with VP, and alpha is the inclination with of front view. And beta is the final, that is the inclination with of top view, that is AB. And this is the final answer. And the students are advised no need to draw step 1 and step 2. This is for understanding purpose. Directly you can combine step 1 and step 2 and finish it with the final step itself. This diagram represents the final answer for the given question. And need not to draw this step 1 step 2 is for only understanding purpose. And finally, all dimensions are written, all dimensions are in mm shall be written below your drawings. And further, one more step is to consider that this A dash B1 is a true length, TL, marked as a TL. TL represents the true length of the given line 100 mm. And this AB2 will also give the true length. It's indicated by TL. TL represents a true length 100 mm. Here also 100 mm. And both are combined to form a final step called step 3. And if you measure the distance A dash B dash, as the line is inclined to both the planes, here the question is given like this. Line is inclined to HP as well as inclined to VP. So final answer, that is A dash B dash, will be shorter in length. Similarly, according to the given question, AB will also be shorter in length. Yes, completed. Thank you for listening.